Hello, today we're going to talk about long division of polynomials. Before we actually get started with that, I want you to kind of review just doing long division of just regular old numbers like we did in elementary school. So take a look at this one right here. We've got 38,512 and we want to divide that by 14. So how do you go about doing that? Now, I always find it interesting that students, even in 11th and 12th grade, struggle with this. And the reason why I feel like they struggle with it is because we learn it in elementary school and then we never see it again. That's why that show, Are You Smarter Than Fifth Grade, is so popular, because we learn a lot of stuff in elementary school, and as we get older, we forget it when we don't use it. After we learn this, usually, we normally jump to calculators when we need to do something like this, and we don't do it on pen and paper. So just to remind you of how this is done, we say, how many times will 14 go into 38? Well, it goes in 2 times. And then we say, okay, 2 times 14 is 28, and we subtract. And when we subtract, we get 10. And 14 will not go into 10, which is good. If it does, then we didn't take the highest number. Bring down that 5. And now the question is, how many times will 14 go into 105? And after a little trial and error, you get 7 times. Once again, you want to do 7 times this number right here, 7 times 14, and I get 98. And I want to subtract that. When I do, I get a 7 right here. Bring down this 1. 14 will go into 71 5 times. 5 times 14 gives me, let's see here, it gives me 70. So I'm going to say subtract 70 from that, and I get a 1. Bring down this 2 right here. And there's a couple ways we can go about this. Sometimes you might have learned to say put a decimal point there, add a 0. That's if we want a decimal. But since we're out, I'm going to stop right here and say 12 is my remainder, and 12 is still being divided by 14. So I write it as a fraction, and right there is my answer. Okay, so that kind of recaps the process that we have to do when we divide out numbers. Now we're going to take that same thought and we're going to apply it now to polynomials. So let's see how we do that. Now suppose I have x squared minus 2x minus 48 and I want to divide it by x minus 8. You say, why would you want that? There are several reasons, and as we progress through this lesson, we'll see some of those, and in some of the other lessons we'll find out why as well. But either way, right now we're just going to figure out how do we divide it out. And so it's going to be similar to what we did with long division. This time we're going to say x goes into x squared. So I'm looking at that first term here, x, and I want to say how many times will it go into x squared? And I say, okay, it goes in x amount of times. And just like what we did down here, we said, okay, 14 goes into 38 twice, so 2 times 14 is 28. I'm going to do a similar thing here. I'm going to say x times x minus 8. So x times x is x squared, and x times negative 8 is negative 8x. Now, last time when we were doing the old way here, we said 2 times 14 is 28, and we said subtract that number. We're going to do the same thing here. Now, it can be confusing sometimes because we're going to get these negatives and positives sometimes. So what I like to tell students is to just flip all the signs and add. So when I do that, I'm going to flip those signs and then add them up. An x squared plus a negative x squared gives me 0x squareds. And then negative 2 plus 8 gives me a positive 6x. Now, just like last time when we brought numbers down after the subtraction part, we're going to do the same thing here. We say bring down that negative 48. And then we're going to say, okay, same process is going to get repeated over again here. How many times will x go into 6x? Well, it goes in 6 times. So I'm going to say that's a positive 6. And now, once again, we're going to multiply. 6 times x gives me 6x, and 6 times negative 8 gives me negative 48. Do not forget to go back, and before you do this, before you add them up, is to flip the signs. So I get negative, or 6x minus 6x, which is 0. Negative 48 plus 48 gives me 0. And so my remainder is 0 here. And here's the first applicable part of this, is that we can automatically know that x minus 8 goes into this evenly. It goes in x plus 6 amount of times, which means x minus 8 is a factor of x squared minus 2x minus 48. In fact, if we factored this, we would get x minus 8 times x plus 6, which is nice. You know, sometimes we need that because sometimes it's not so easy to tell how do we factor this right here. And so we can use, you know, if we have a clue of what will go into it, we can use division to figure out the factors of a polynomial. All right, they don't always work out so perfect. Sometimes you do have remainders like we do with regular real numbers, and we're going to see that in some of the examples as well. So let's take a look at another one. Let's suppose we have, here, let me move this out from underneath, x squared minus 2x minus 48. Actually, no, that's the one we just did. Let's pick out a different one here. Let's try 4x squared minus 2x plus 6, and this time I'm going to divide it by 2x minus 3. You can pause the video if you want and give it a try. I can tell you that it will not go in evenly. You're going to get a remainder here, and we're going to do the same thing we did in the last one when we get a remainder. All right, so if you've paused it, given it a try, let's do it now together. 2x, that first term there, goes into 4x squared twice, right? Actually, 2x times. So I'm going to write 2x right here. 2 times 2 is 4, and x times x is x squared. 2 times negative 3 is negative 6, and you're multiplying it by an x as well. I'm going to flip those signs and add, and I get 0 when I add those up. These two added up give me 4x. Bring down that 6. 2x will go into 4x twice. 2 times 2x is 4x. 2 times negative 3 is negative 6. Don't forget that we need to flip the signs and add. And remember, the only reason why I'm saying flip and add is it's the same thing as subtracting here. So when I say 4x minus 4x, I get 0. When I say 6 minus a negative 6, it's the same thing as adding 6. It's just easier for me to think of it as flip the signs and add. So when I do that, I get 12 right here. And then 2x will not divide into 12 evenly because there's no x term there. So this right here is my remainder. Just like when we were doing the regular numbers, we had a remainder a second ago. Just so happened to be 12 also. Okay, it won't always be a remainder of 12. It's just coincidental. And so what did we do with that 12 when we had it as a remainder? We said it's still being divided by 14, so we put it as 12 over 14. We're going to do the exact same thing here. We said 2x minus 3 goes into all this mess 2x plus 2 times. So 2x plus 2 times. And then we had that remainder of 12. So I'm going to put that 12 and still divide it by 2x minus 3 right here. That's going to be my answer, okay? That's how many times 2x minus 3 goes into that. 2x plus 2 plus that remainder there of 12 over 2x minus 3. All right? Now, I know what you're thinking. You're like, maybe if you're in pre-calc, you've had this in Algebra 2, and you're thinking, you know, well, there's an easier way to do this with synthetic division. We are going to cover synthetic division in the next video, but there are times when synthetic division doesn't work or it's not as easy as just doing good old long division. So it does have its value, and that's why I'm going over it. All right, let's try out another one here. Now, this one is x cubed minus 6x squared plus 1 divided by x plus 2. And before you pause the video, hopefully you haven't done that yet, I want to give you a hint on what needs to be done here. Now, you can try if you want to before I give you that hint, but if you want to see the hint first, notice one of our main rules here, what we're dividing into, we've got to have it in descending order, x cubed, x squared, that's good, and then we can't skip over any x's. So if you start out at 3, it's got to go 3, 2, 1, 0. And so it's like we've got x to the 0 right here. That's fine. But we're missing x to the first power. So when we write this out to do long division, we need to put that in there. We've got x cubed minus 6x squared there is no x to the first term here, so we got to write that down. 0x to the first, and then you don't really write the 1 there, but 0x, and then plus 1, which is the same thing as 1x to the 0, right? And that's what we're dividing by x plus 2. So don't forget to do that, okay? Make sure you have that placeholder there. That's needed. Otherwise, you'll get into a jumbled mess and you'll wonder what happened there. So I'm going to go ahead and work this one out now. X goes into x cubed, x squared times. X squared times x is x cubed. X squared times 2 is 2x squared. Remember to flip your signs so that becomes negative, that becomes negative, and add them up. This gives me a negative 8x squared here. Bring down your 0x. X goes into negative 8x squared, a negative 8x times. And then multiply. Negative 8x times x gives me negative 8x squared. Negative 8x times 2 gives me a negative 16x. And then flip your signs and add. These will cancel each other out. And 0 plus 16 here gives me 16 x's there. Bring down that term right here, plus 1. X goes into 16x 16 times. 16 times x is 16x. 16 times 2 is 32. Flip those signs and add. And I get a negative 31 there. X will not divide into that, so that is my remainder, which means my answer is written like this. This right here, x squared minus 8x plus 16, and then that negative 31 is the remainder. It's still being divided by x plus 2. So I put the x plus 2 right there. And this is technically being subtracted from this. You could say adding a negative if you want to. And that is your answer for that one. Let's try out one more example so you've got plenty of examples to try out. I'm going to say 6x squared minus x minus 7. So 6x squared minus x minus 7. And we're going to divide that by 3x plus 1. Now, notice on this one, we've got it in descending order 2, 1, 0. We don't have to put any placeholders in this one. So I can just start right off by setting up my long division. 3x goes into 6x squared 2x times. Multiply. 2x times 1 gives me 2x right here. I'm going to flip those signs and add. And I get negative 3x. Bring down the negative 7. 3x goes into negative 3x a negative 1 times. Multiply. Negative 1 times 3x. Negative 1 times 1. Flip the signs and add. We get a negative 6 right here. And that's going to be our remainder because 3x will not divide into that evenly. So how do I write my answer? Well, it's 2x minus 1 plus the remainder divided by that divisor right there, 3x plus 1. Boom. We're done with that one. Okay? Now, maybe you're thinking this is a pain. And I think it kind of is sometimes, although I have fun doing it. I don't know how many problems I want to do like that, but sometimes I get, a little bit of a kick out of doing that. I would suggest that once you learn synthetic division, when you can use synthetic division, you're probably going to use synthetic. But it's nice to have this tool for when you cannot use synthetic division. I know some students, when they come in my class, they absolutely hate synthetic division. They're like, oh no, not synthetic division. I remember that from last year. Give it a try this year, okay? So I'm going to do another video on synthetic division. You can watch that, and then you'll have both ways here that you can do it. Two good tools to have when you're dividing polynomials, okay? Thanks for watching, and I'll see you in the synthetic division video.